Alright, we're back to some take-home physics, and we will talk a little bit more about going in circles. I have a little background noise here for you. That's on purpose. We will learn what it has to do with coffee and coffee mugs with hula girls on them. Huh? What you guys have seen before is this, and what it represents is the Earth going in circles. That could be the North Pole. That's the equator. And the different coins represent changes in latitudes. So if you're at different latitudes, you make different sized circles in one 24-hour time period. And what we're going to do is just calculate the rate at which you're moving, even if you're sitting still, doing nothing, whatever that's like. We got a couple weeks of a whole lot of nothing coming up, don't we? So, even sitting there, just due to the Earth's rotation, you're going in circles, I promise. And different latitudes will tell you what your different rates of circular motion is. Alright? So what you're going to do is figure out the miles per hour at which you're going in circles, sitting here doing nothing in good old Cincinnati, USA. Alright? The way I will demonstrate that is to make some circles here, and what I'll do is show you what that's going to look like. So, as I said before, we have coffee mugs with hula girls on them, right? This is the lid of a coffee can, and I'm going to use that to show you how you're going to calculate the miles per hour at which you are going in circles by simply doing nothing. So this will represent the planet Earth. That's the center of the Earth. This will represent the equator. Okay? So from here to there, I'm going to call capital R. That's the radius of the Earth. Now, that's at latitude 0, isn't it? And if we follow Jimmy Buffett's advice and change our latitudes, maybe we'll end up right here-ish. And the reason I picked that is Cincinnati. It's not perfect, but it's dancing around 40 degrees latitude, which it's like 39-ish. I always round it to 40. Okay, so if I draw that, since it's still connected to the center of the Earth, that distance is the same as that distance, isn't it? It's just one Earth radius. So I'm just going to call that big R. Okay? But if I were to drill a hole and go from the equator to the center of the Earth and go perpendicularly straight up, this is where Santa Claus lives. It's Santa! And down here is, I don't know, where penguins dance. Then we have North and South poles, right? So going from the equator on this radius, boom, straight to that north-south line is a different distance than if I go from that latitude directly inward to that north-south line, isn't it? So this distance is bigger than that distance. And what you can Z is there's a letter Z there, isn't it? So this is parallel to that. Which means if that's 40 degrees latitude, that's a 40-degree angle. And since this and this is just what, those parallel lines with a bisector, alternate interiors, that means that's a 40-degree angle, doesn't it? So if that's a 40-degree angle, and I know this R, well, that R becomes a hypotenuse for a triangle, right? So that right angle there, with that hypotenuse, with a 40-degree angle, which is ish, the latitude of Cincinnati, again, it's like 39-ish, but I'm going to call it 40, means we can very easily figure out what the radius, a smaller radius is, of the Earth if I were to slice the Earth in pieces right at the 40-degree latitude mark. It would be like slicing an orange, but not right at the dead center. Slice it somewhere up there. That radius is going to be small. And so the circle that you make by doing absolutely nothing due to a 24-hour rotation of the Earth is the circumference of a circle with that small r radius. So what we're going to do is we're going to say, well, we got to figure out that r so we can figure out the circumference. This radius, then, what hopefully you can tell, is adjacent to that 40-degree angle. And if it's adjacent, then that's the ka, and so ka to where. So that's adjacent. That's going to be a cos. So if I know this radius, which you do, because it's the radius of the Earth, it's the same as the equatorial radius, then what we'll do is we'll say, gosh, that must mean that the cos of 40 is equal to adjacent, which is little r, the radius that we're looking for, the radius of the circle that you are making, whether you're moving or not, just due to the rotation of the Earth, hanging out at a 40-degree latitude, divided by the capital R, which is the radius of the Earth at its equator, which is for the most part the same as the hypotenuse of that triangle made going towards the north-south line. Okay? Which means little r is equal to big R multiplied by the cosine of, in our example, 40, because we happen to live in Cincinnati, which is close enough to a 40-degree latitude. I think it's 39 something. I'm sorry, I don't remember. All right? But anywho, that is how you can figure out the radius of the circle that you make when you're sitting at home, locked inside your house, not doing anything, and the Earth is still rotating. So, you know, the planet Earth time don't stop just because you don't go to school. You can figure out that radius, and you can figure it out based on any given latitude. All you have to do is change that number 40. So if you're having changes in latitudes, then you're having different velocities. So what I'm going to have you guys do, this is your assignment. I want you to tell me the radius of circles that people make at 4 different latitudes. One is 0, which is the equator. And then another, so r equals r cos 0. Now, when you get better at the unit circle, you'll know the cosine of 0 is just 1. So little r equals big R times 1, which makes sense if you're hanging out here. That r is going to be the same as that r. And then as you go up, eventually you will get to 90 degrees, won't you? Santa Claus just spins like this. He doesn't make a bigger circle, all he does is just something about yay. And that makes sense because, when you get better at the unit circle, you'll know that the cosine of 90 is 0. So that little r, which would be this line, is equal to the big R multiplied by 0, which means it's a whole lot of nothing. So, figure out that little r as you're having changes in latitudes. So one will be 0, one will be 40. Do one for some folks where you're going to head to in spring break a little, not too long from now, maybe down in Daytona. Look up that latitude. I don't know, Panama City, Destin, whatever. Hawaii, look up that latitude, see where we're at. And then do one for some folks up in Canada or Alaska or whatever. Remember we said in class that hula girls dance faster than Eskimos. And so that's another part of what we're doing. So tell me the R for 4 latitudes. Then do that in miles. In miles. Okay, so when you look up big R, the radius of the Earth, you're going to need to look it up in miles. And it'll be easy to find, just the radius of the Earth in miles. And all you're going to do is multiply that by the cosine of 4 different angles, whatever latitudes you're doing. Okay? Once you have that radius for 4 different miles, multiply it, or for 4 different latitudes, multiply it by 2 pi, and that will equal the circumference of that circle that you're making by laying on the couch doing nothing in miles. Okay? That'll equal the circumference of that circle in miles. Then divide by 24, because that's how many hours it takes you to make that circle, and that will be the miles per hour that I promise you are moving, whether you're moving or not. So while we're sitting here in quarantine, not moving at all, forced to stay in the house, you guys are still being able to move at quite a velocity due to just the Earth's rotation. All right, so 4 different latitudes. All you got to do is look up the radius of the Earth in miles at the equator, and it'll tell you that. It's pretty easy to find. Multiply that by the cosine of whatever different latitudes you want to talk about. Make sure one of them is 40, though. Or if you want to use 39, whatever, it doesn't matter to get more Pacific to Cincy. Then multiply it by 2R. Tell me the miles per hour, okay? When you guys get those numbers, what I'm going to have you do is write out the math, then take a picture of that math that you wrote on a sheet of notebook paper and submit it to Schoology. I will create a quiz, although it won't be graded as a quiz, but it's the easiest way to submit homework into Schoology. And in that quiz, it'll just say, hey, the circumference of, or the miles per hour at different latitudes. Once you guys have that, just drop it in there as a photo of the math that you guys answered. And that's it. And then that'll be due by 11:59 on Wednesday. Okay, today is Monday the 23rd, so Tuesday's 24, Wednesday is 25. March 25th, midnight. Make sure you have a picture of that submitted onto that Schoology page. And then for Friday, I will have another assignment due where you'll do the same thing, but you'll calculate how fast you're moving due to the Earth's rotation or revolution around the sun. And so we can push the plus button or the minus button to just see how fast it is you're moving. Even though you're stuck in the house in this quarantine, you're still going places, kid. I promise. Physics isn't quarantined, all right? So thanks. Sorry we can't do this in person. I do miss you all. Yay, physics.